going to start, this is going to be solving systems algebraically. And I'm going to put, what is today? Algebraically. Today is 9/17. This is page 5. And this is period 5. So I'm just going to leave it right there. We have two methods we're going to review. Now you may have seen this in Algebra 1, but it's been 2 years, basically. So that's why I'm just starting over from scratch. Meaning, you may have completely forgotten about it. So we'll start with substitution. It's exactly like it sounds. What you do is you take one variable, you got both x and y, so you take one of them and you're going to plug in what it's equal to into the other equation. When you do that, you'll only have one variable. So you'll solve for one of them, and then you'll go and you'll solve for the other one too. Then solve for the other one. That is the basis of substitution. I'm just going to make it a little bit pretty and substitute that. And the example is going to be from the worksheet. So it's going to be number 5. 3x minus y equals 0. And 2x plus y equals negative 10. Why?
Something happened to my family.
So can you wait till the office sends for you?
No, I gotta go.
Okay, can you check into the office on the way out? Please, so that they know you're leaving? Okay. I'll post these notes later on today so you'll know where they are?
Yes.
Okay. So what we're going to do is we're going to take either one of these variables, either this y or this y. See how there's no coefficient in front of them? That's when I want to use substitution. So you might want to make a note. Use substitution when one of the variables does not have a coefficient, a single y. And what you're going to do is change it so it's y equals. Now, it doesn't matter which one you pick here, because this is a single y and this is a single y. But if I was going to pick, I would pick this one, because in order to get y alone, what I'm going to do is add y to both sides. And I can see that that gives me a positive y equals 3x. Now, I'm going to take this 3x, y equals 3x. And this y and these x's, they're all the same. Okay, so you can substitute one for the other. So since y is equal to 3x, I'm going to substitute this into here where y is. Substitute here. And then my equation becomes, I've got 2x plus, here's my 3x, and that is equal to negative 10. Right, this is your 3x that you got from the other equation. So Shelby, what would you do next? Sorry, I know I write fast. Yes, Jack, what would you do? Right. So you're telling me how to do the whole problem? I'm just asking what would you do next.
Oh, sorry.
That's okay. I would add those together, right?
Yeah.
Okay, so I get 5x equals negative 10. That makes sense, right? Good. And Nozomi? Oh, you're okay. Okay, so I have 5x equals negative 10. What's the next thing you'd do? Yeah, perfect. That's what I would do too. So I get x equals negative 2. Right? And I'm not going to box it actually. I will tell you why in a minute. But I am just going to highlight it. I've got x equals 2. So remember when I said, okay, then you'll have one variable. Then, these are two lines that cross each other, right? And that's only the x. So now we have to go back and get the y too. So you're going to take this negative 2 and you're going to plug it back into either equation. Both of them will give you the same y. So Will, which one would you pick? This one here on the left or this one here on the right? On the left? And just out of curiosity, why would you choose that one? Yeah, it's easier, isn't it? This one has less numbers and stuff, so pick the easiest one. So you'll take this negative 2, plug it back into either equation, in this case we'll pick that one, and I get 3 times x is negative 2, and I get minus y equals 0. I always go back to the original, just in case I made a boo-boo somewhere. I always go back to the original, but that gives me negative 6 minus y equals 0, and add y to both sides, and I get that. Now, Jack, why did I not box those?
Because they're individual values.
Right. What should my answer look like? When two lines cross each other?
You should have the point where they cross.
You should have the point where, exactly. You're looking for the intersection. So your actual solution, what you'll see on my answer key is an ordered pair where the x comes first and the y comes second, and that is what I'm going to box. Okay, this is your final answer right here. Beautiful. Is this sounding kind of familiar to you guys? Thank you for the head nod. I'm seeing a couple of you. Okay. So again, you want to choose this method if one of your variables doesn't have a number in front of it, if one of them is a single. Now, if they all have numbers, we're going to turn the page and we're going to do elimination. Yep, go right ahead. That's why I'm looking at you. I see you. I see you. Okay. Plus, you can always take a picture. Thank you, Shelby. Sorry to rush you. Okay, so now we're going to go over elimination. Second method. And I just want you to write one sentence on the object here. So what you're going to do for elimination, let me just write page 6, hold on, is you're going to multiply one or both equations so that one of the variables drops out or cancels. That'll help? Okay. So now, if you'll look at, where's my worksheet? It's right here. Yeah, our problems. These problems here, elimination, what I was going to do is number 9, but that's actually fairly simple because you don't have to multiply. But see how number 11 has bigger numbers? I thought maybe we would do 11 together. Okay, so this is the one I'm going to do instead. So 10x minus 9y equals 46. And then I want you to do me a favor. Whenever you're doing elimination, write them vertically. So the other problem is going to be negative, oh, I forgot my x. Negative 2x plus 3y equals 10. Let me just make that a little prettier. All right, so everybody with me on this? I'm going to go over also like why you would pick this. So our object here is we want to either make the x's go away or we want to make the y's go away. So you can do either one. You get to choose. You're going to solve for both anyway. If I look at these x's, just the x's, what number could I make this one into so that they would both cancel? In other words, what could I multiply this one down here by so that they would cancel out? Nozomi? Yeah, a 5, right? So you can see if you multiply that by 5, you'll get negative 10x, and this one positive 10x, and that would make it go away. But let's say I want to make these go away. Okay, now if you're only looking at the y's, what common number will make them drop out? You see what it is, Jack?
Yeah, multiply 3 by 3, 9 by 1.
So if they're multiplied by 3, the bottom one, right? Just the bottom.
Just the bottom.
Then I get minus 9 and plus 9.
Yep.
So at this point, Sam, I want you to pick for me. Do we want to multiply by 5 to make the 10s, to make these go away, or multiply by 3 to make the y's go away? Just pick. You would do the 5s? Okay. So we're going to multiply the bottom by 5 so that the x's go away. And I do it on both sides, of course. It doesn't matter which one you pick, so that's why we're picking 5, because I said pick one. And then you're going to distribute this 5, so you end up rewriting it down here, okay? So take an extra step here, and then 5 times negative 2x will give you negative 10x. Plus 5 times 3y will give you 15y. 10 times 5 will give you 50. Is that pink showing up okay for you, Donia? Brayden? Can you guys see it? All right. Because the orange does not show up nearly as well. I don't know why. Now that I have this multiplication, I'm going to go with the original equation. You can either rewrite them both if you want, or you can just like put a star on them. These are the two I'm going to combine. So combine these two equations. And watch what happens. 10x minus 10x gives me nothing. I'm not even going to write it down. Negative 9y plus 15y, that's going to give me 6y's. And then 46 plus 50 is going to give me 96. That's the point of elimination. It just sort of makes one of them go away. Blaine's not here. Donia, what's my next step? And then y equals, I believe that's 16. 60 and 36, yeah. Okay. So y equals 16. So Sam, what's my next step? Yeah, now I got to plug the y. Exactly right. So I'm just going to write this because these are notes. Plug the y back in. Does it matter which equation you use to plug it back in? I'm seeing some head nods. No, of course not. Because it's the same x and same y. So is there one you would rather pick? Yeah, Will? The one on the bottom? And you would pick that because? Yeah, it's less numbers. Just make it easy on yourself. Nobody says you have to pick the big one or the one on top. Just find whichever one you think's easier. And yes, I definitely think those numbers are smaller. So so then negative 2x plus 3 times what I got for y, that's a 16, is going to give me 10. And you solve it like a regular equation. Francesca, what am I going to do next? Yeah. That's what I love about you guys, because you're always so careful when you rewrite stuff, and it's really nice to see your conscientious work. Brayden, how am I going to solve for x here? What's going on next? Miss Blythe's class is being so loud I can't hear you. What would you do next? Yeah, I'm going to subtract. Exactly right. So I have now isolated my x. Will, I picked your stick, so you get to tell me what to do next. I know you volunteered before, but I have x multiplied times negative 2. So I want to undo multiplication by negative 2. What are you going to do? Yep, exactly. That's exactly right. So now I have 1x, and it's equal to, what's negative 38 divided by negative 2? Jack, do you know what that is? And what you would also do, if you need a calculator, you grab a calculator. Okay? It's okay.
I've lost all math skills ever since I was allowed to use
Yeah, that's one of the problems. All right, next.
Thank you.
Last step. What's our last step? Yeah, you have to write it as a coordinate, because this is where the two lines cross. So the solution, it's not just leaving them x equals blah, blah, blah. The solution is an ordered pair where x is 19 and y is 16. Got to do that. That is what your answer key will look like. And if you graph them, they would both cross each other at 19, 16. And that's the end of our notes.